Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hope you're having a good day today. So now in this video, we're going to talk about the computer processing of human language. As now, we are living in a 21st century, we are in the era of technology. We have computers that are now developed and now more advanced. So, computers and linguistics has something to do with. So here is a computational linguistic wherein it is a subfield of linguistics and computer science that is concerned with the interactions of humans and computers. So, computational linguistics is used in tools like instant machine translation, speech recognition system, text-to-speech synthesizers, interactive voice response system, and search engines. So, computational linguistics includes the analysis of written text and spoken discourse, the translation of text speech from one language to another, use of human language for communication between computers and people, and the modeling and testing of linguistic theories. Computer that talks and listens. So, as of now, as we humans, we are looking for a computer that is ideal for us. An ideal computer for now is a computer wherein it is multilingual. It speaks both computer language and also human language at the same time. It would be helpful if we could communicate with the computers through our native language. So, imagine having a computer wherein it knows our own native language. It understands us as we speak on our native language. So, because of this, especially when we are working with our computers, our work becomes easier and faster because of the convenience that our computers gives us. So, computational linguistics is concerned with the interaction between language and computers. So, from phonetics to pragmatics, from producing speech to comprehending speech, and from spoken utterance to written forms. Computational phonetics and phonology is concerned with processing speech. Its main goals are converting speech to text on the comprehension side and text to speech on the production side. It has two sides: the speech recognition and speech synthesis. So, what do we mean? What does speech recognition means? So, speech recognition is the process of analyzing the speech signal into the component tones and phonemes, and producing in effect a phonetic transcription of a speech. The next one is a speech synthesis. So, speech synthesis is a process of creating electronic signals that stimulate the tones and phonetic features of speech and assemble them into words and phrases for output to an electronic speaker. Early speech recognizers were not just designed to hear individual sounds. Computers were programmed to store the acoustic patterns of entire words or even phrases in their memories. Advanced speech recognizers may also utilize syntactic rules to further disambiguate an utterance. For example, if the late and the rate syntactic context is it's to, therefore the word will be late. It is late because the word to may be followed by an adjective, not by a noun or even a verb. Computers are not nearly as capable as people in coping with noisy environment. So noisy environment. So computers have also a disadvantage wherein if malfunction, especially in a noisy environment, computers can really understand what does the people are talking about, especially in a noisy environment. So it would just lead into misunderstanding or malfunction. Speech synthesis is a artificial production of human speech. A computer system used for this was called as speech synthesizers. So speech synthesizers, these are the computer system this is what we call to those computer system that synthesize the words or the sentence. The advance in the acoustic theory of speech production and technological developments on electronics machines production of machines.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. By the way, I am Rashika Jane Wamar. So, in this video, I will go into discuss about the computational morphology, computational syntax, computational semantic, computational pragmatics, and as well as the computational sign language. So before that, we must know what is computational is. So computational is something to do with the operation of the computer. So let us start with the computational morphology. Before that, we must also know what is morphology is. So morphology is a study or the description of how words are formed in a language. If we wish our computer to speak and understand grammatical English, we must teach them morphology. We cannot have machine going around saying that cat is sit on the mat. Similarly, if computers are to understand English, they need to know that sitting contains two morphemes. Sit plus ing, whereas spring is a one morpheme. And reinvent is a two, but they are reinvent and not reinvent. One approach is placed in a morphological form of all words in the language into computer dictionary. Although today computer can handle such a high computational load, many millions of forms would be still a problem because of the generating of the process. As soon as we know the word enters the language, as Blag did some years ago, a whole family of words is possible, wherein blag, blogging, log, or reblog, and many others are not possible or seems unlikely. We cannot predict. So moving on to one method of morphological analysis is called stemming. Here, affixes are detected and repeatedly stripped off by the beginning and the end of the word, checking the work against the computer dictionary. For example, if the word to be analyzed is befriend, the computer would recognize and verify the prefix be and then the suffix en, leaving behind the root friend, all of which would be verified in a dictionary of words and the morphemes. So moving on to the computational syntax. So what is syntax is? Syntax is a way in which words are put together to form phrases, clauses, or a sentence. So to understand a sentence, you must also know its syntactic structure. Similarly, machines that understand language must also determine syntactic structure. A parser is a computer program that attempts to replicate the structural knowledge that speakers possess. For example, a parser may contain the following rule. The first rule is that a sentence is often a noun phrase or a subject followed by a verb phrase or predicate. Second rule is that a noun phrase is often a determiner followed by a noun. For example, the sentence is the child found the kitten. The top-down parser proceeds by the first consulting the grammar rule and then examining the input stream to see if the first word would begin a sentence. If the input stream begins with the determiner such as the word that, as in the example, the search is successful and the parser continues by looking for the noun and then verb phrases. But if the input stream happens to be the child found in the kitten, the parser would be unable to assign it as a structure only to the missing determiner and would report that the sentence is ungrammatical. So the bottom-up parser takes the opposite tack. It looks first at the input string and finds the determiner, which is the lead, followed by a noun child. Rule number 2 tells that this phrase is a noun phrase. It would continue to process found, the, and kitten to be contract a verb phrase and would finally combine the two into a sentence. So moving on to the computational semantic. So what is semantics is? Semantics is refers or relating to the meaning of the words or phrases. It is considered to the representation of the meaning of the words and the morphemes in the computer, as well as the derived from their combinations. So computational semantics has two chief concerns. One is to produce a semantic representation of a language input, which is the speech understanding, and the other is to take a semantic representation and produce natural language output that convey meaning, which is the speech generation. So, for example, consider this expert from the spoken dialogue system called the Circuit Fix It Shop, designed to help a technician repair the faulty circuit. Computer, this is a circuit fix app. How may I help you? Technician, I need to fix the RS111 circuit. Computer, I am familiar with the circuit. The lead is supposed to be displaying alternately blinking 1 and 7. Technician, where it is the lead? Computer, in the middle right of the blue region is the lead. Technician, no light. Computer, what is the switch at when the lead is off? Technician, the switch is shut down. Computer, you put up the switch. So, to generate this sentence, the computer tries to find words that fit the concept incorporated with its semantic representation. In the circuit fix-it-up shop, the computer must decide what to talk about next. The switch, the user, the light, or whatever. It needs words corresponding to whether to describe the state of an object in its purview as about the state of an object. And the user's purview, make it the request of the users. Tells the users what to do next and for. When the computers or components of the meaning are assembled, the syntactic rule that we have been seen already are all upon the produced grammatical output. To achieve speech understanding, the computer tries to find concept and the semantic representation that fit the word and the structure of the inputs. When the technician says, "I need to fix the RS111 circuit," the system recognizes that "I" means user, that needs represent something that the users lack and the computer must provide. So far, moving on to the computational pragmatics. It is the interaction of the real world with the language step. The semantic processing routine can refer to the knowledge base in the cases of ambiguity. For example, the syntactic component of the circuit fix it shop will have two structures. For the lead is in the middle of the blue region at the top. So the sentence is ambiguous. Both meanings are semantically well-formed and convincible. However, the circuit fix it shop knowledge base knows that the lead is in the middle of the blue region and the blue region is the top of the work area, rather than the lead is in the top of the middle part of the blue region. So it uses pragmatic knowledge, a knowledge of the real world, or to disambiguate the sentence. Moving on to the computational sign language. So the researchers are working on the computer algorithm with the recognized sign language match in the same way that the speech may be recognized. Signer may sign in front of a camera and the computer will attempt to match the same sign from the set of the pre-stored sign via visual processing. Visual processing, is this the case, means detecting the shape and the gesture of the hands, and their trajectories and their orientation. There are difficult algorithms for construct and success has so far been limited. The purpose of these enterprises is in the two folds. The first one is to produce video presentation dictionary of sign. Someone who can imitate a sign but does not know the meaning can look it up in the video dictionary, just in a one uses of an ordinary dictionary to look for a written word. The second purpose is that enables computer to search through ALS video for a particular sign. Just a search engine look Google searches for a certain key word in the text document. So that's all for my video representation. Thank you and wassalam.
Assalamualaikum. I am here to discuss to you what is the applications of the computational linguistics. I will discuss to you about the usefulness of computers and the various subfields of computational linguistics, such as natural language interfaces to various kinds of computer programs. So let's proceed to computer models of grammar. As a 21st century youth, we are aware of how computers work, right? And when it comes to texts, there are an obvious grammar checker. But the grammars used by computers may not be the same as the grammars that linguists construct for human languages, which are models of linguistics competence, nor are they similar. Computers and people are different, and they achieve similar ends differently. For example, there were a lot of efficient flying machine but is not a replica of any bird, at least not yet. So efficient grammars for computers do not resemble human language grammars in every detail. Grammars are infinite in scope. An immense or prodigious amounts of testing are necessary to verify their linguistic description, and that's where computers play an important role. However, even though computers was created to model the linguistic description of human grammar of a language, it does not capture an accurate grammar, one that is a true model of a speaker's competence. Example, If you type the word that is unfamiliar, it will be ungrammatical, right? Did you also notice? And the font of the words will be color red that indicated wrong. So during the 1960s, the computer models of linguists, grammars, a lot of known syntactician test the generative grammar of English. Such models are still being used till today. So to develop test newer theories of grammar, the computational models shown that it is possible to use a written down grammar in language production and comprehension. That is at least a partially successful description of human competence, but it is still controversial whether such grammars are true models of human language processing. So let's proceed to frequency analysis, concordances, and collocations. The one who proposed about the one kind of application of computers to language was Jonathan Swift. The statistical analysis example of the general proportions of letters and sounds, morphemes, words, word categories, types of phrases, and so on may be swiftly and accurately computed for any corpus. Corpus is a body of language data, whether textual or spoken. Yes, that is the meaning of corpus. So let's proceed to moving on to the differences between spoken and written language is that it is demonstrated by corpus analysis. For example, in corpus analysis, there is a frequency analysis of 1 million words of written American English. Reveals the 10 most frequently occurring words was the word da, of, and, to, an, in, that, is, was, and he. So these little words accounted for about 25 of the words in about the corpus, with the leading the pack at 7%. A similar analysis of spoken American English produced somewhat different results. The winners were I and the, to, that, you, it, of, a, and no, accounting for nearly 30%. What is a concordance? A concordance takes frequency analysis one step further by specifying the location within the text of each word and its surrounding the context. So a concordance of the paragraph preceding the previous one would not only show that one word occurred 5 times, but would indicate in which line of the paragraph it appeared and provide its context if one choose a window or the 3 words on either side for context. The concordance would look like this for words. So this is shown my video. So of 1 million words of written American, most frequently occurring words was the, of, and. These little words accounted for about percent of the words in the corpus, profane and taboo words. You can check that on chapter 7. So a concordance, as you can see, might be of limited usefulness because of a concordance uh, because of its raw nature. A way to refine a concordance is through allocation analysis or collocation analysis, I mean. So a collocation is the occurrence of 2 or more words within a short space of each other in a corpus. The point is to find evidence that the presence of one word in the text affects the occurrence of our words. Such an analysis must be statistical and involve large samples to show significant results. In the previous concordance of words, there is not enough data to be significant. If was performed a concordance on this entire book, patterns would emerge that would show the words and written words and taboo, and words of are more likely to occur close together than say words and million.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. And good day, Ma'am Ada. This video is our report in final. With my group mates, I am group 2. The topic of our video is about the computer processing of human language. As we know, the language is connected to computer because we use the language in computer to understand what about inside the computer and to understand how to use the computer. So the topic given to me is about the cultural revolution. Cultural revolution, means reveal many details of language change. So it's all about the changes of language. Once upon a time, a 1 million word corpus of written English was the cat was called meow. After today, in 361,000 years, the cats called meow, today it's just called cats. And have rounded to create a 361 billion with A-B words corpus of English. Before, there have no alphabetic words, and after for how many decades, the study of language made the alphabetic words. So that is the cultural revolution. The words are grown from about 5 million books, representing 4% of books ever published in English language. Analysis of this corpus, a study termed culturomics. It is called the culturomics, the study of changing of words. So the corpus means a collection of language data gathered from spoken or written source used for linguistic search and alphabetic. It is the collecting words in the English language. It's called corpus. The cultural revolutions has also produced resort on the historical changes of irregular verb. As we observe, the verb is changing from past tense from present to past tense, and it's have the regular and irregular verb. Before the example of irregular verb, dog and changing to dive, that therein to supplant them. The cultural analysis inform us that in the period between the 1800 and 2000, the 6 irregular past tense verb was changed. Before, the example from it is burn, from the irregular verb burn changed to brain, and in the ended of empty. Child changed to child, the smell changed to smell, and spell changed to spell, spit changed to spit. It is changed the smell from the ending of S-M-E-L-L, it just changed to S-M-E-L-T. It's become the that is the example of changes of irregular verb. So is the changing of regular verb. But at the same time, 2 regular past tense verb, light to lighten. In the present, light, then the past, lighten. And wake, the present wake and wake and ended ed became irregular, like light, past present light to light. It's like example, light before it is the regular verb in past tense. Then after the many years of change, it's become the light it's become a regular verb in past tense. Another example, so as we observe, the past tense of week can be changed to irregular verb walk. And it is all about the culturomics revolution, the changing of the word in every years or every decades. Next is the information, retrieval, and summarization. The next is tweetetology. Our expressiveness and our ease with some words in being the like, so that the sentence with more than one clause is a problem for us, and the word of more than 2 syllables is a problem for us. So the tweeterology is the computer analysis of a vast corpus of microblogs known as tweets. As we know, some people using the application of Twitter, it is the inside that applications, the people posting there, it is the word tweetetology. Tweetetology is being used for sentiment analysis by regulating the frequency of occurrence of positive emotion words such as awesome and fantastic, and negative words like panic and fears. This is provide a window into realm of daily life within a country. As the people using the Twitter posting about their happiness, about the awesome happening in their life, their fear, their panic. So the tweetetology is necessarily confined to a very narrow form of communication that's been called tribal and specialized. It is specialized and tribal. So the scientific legitimacy and usefulness of tweetetology is of this writing an often question to be answered with pressure within the second decade of this country. So we used to the question and answer. Some people posting there, then the other person comment. So it is about the questioning and answered. Then next is information retrieval and summarization. Information retrieval, for short, the process of using computer to search a database for items on a particular topic. So when we are studying about the computer, there are the many code in computer language that is belong to the information retrieval. Information retrieval system consists of word statement or question which the computer analyzes linguistically and then uses the resort to sift through the database for pertinent information. Nowadays, complex information retrieval system identify useful pattern or relationship in corpuses or other computer repositories using advanced linguistic and statistical analysis. So the computer is updating about the linguistic. It's connected with the language, and when we are finding the information or documents, it's easy to us by just using the code in the computer language or in computer words. It is belong to the information retrieval. Then and it is the data mining. Data mining, knowledge discovery, data analysis, and analytic are also used currently for highly involved information retrieval system. It is highly used by the people to find the information in computer. The next is summarization program. Summarization program range from the simplistic print the first sentence of every paragraph to complex program that analyze the documents. So, as we know, the summarization is the summarize or to get the words or important words in the books or articles. It is the often using concept vectors. A concept vectors is a list of meaningful keywords whose presence in a paragraph is a measure of paragraph significance and therefore an identification. So we just get the meaningful keyword, the important words of the sentence or the articles to summarize it. So whether the content of that paragraph should be included in summarization. So that the way of getting the keywords of the important words in the articles or in the books, it is included to the summarization. The summary documents contains concept from as many of the key paragraph as possible, subject to length constraints. So it is to make the summarization to get the keywords in the important words. Last is spell checkers. Spell checkers and perhaps in the future, pronunciation checkers are applications of computational linguistics. So spell checkers application is the checking the spelling of the wrong spelling in the computer. We don't need to use dictionary to see the wrong spelling of the words. It will automatically, when we are using computer, it will become red. That means it is wrong spelling. So that is the spell checkers application. That's all about my topic.
Good morning everyone and have a good day. I am Ahmed Sadiq Alburaya, first year, section B, major in English. My topic for today is all about the machine translation. According to the famous philosopher Warren Weaver, he said, "When I look at any article in Russian, I say this really in English, but it has been coded in some symbols of it." So, the aim of a translation is to input an utterance between the passage source language, which is the input and then the output. And the second one is what we call the target language. The target language, it seems like in our 21st century now, is the autocorrect artificial intelligence, which is built in app in our phone, which is the autocorrect. And the second one is about the interpreting the legal terms. And according to William Shakespeare, a Daniel come to judge a Daniel. And then the second one is the speaker identification. The speaker identification is which we cannot see by our eye, and then many crimes involve in the anonymous recorded message in which is important to identify the speaker. That is what you call identification speaker. It says here, it is the use of computer or what we call an AI in such as task and opposed and ear witnessing. For instance, when you are in a judge or in a police stations and then you haven't seen any evidence of it, and then you hear the voice of that particular person, you can identify by hearing it again. And then the second one is the request permission. Although what I'm trying to say is ikaw mo. Trying to say is that to sum up everything that has been stated so far, computational linguistics is the study on how the computer processes language and then allowing it the natural language of human computer, or what we call now an artificial intelligence, as well as the computer can help the scholars to analyze the literature and language. For instance, when we use the language, we can use it in many different aspects. For instance, I'm using an English language, and then the second one is using a Spanish language, like in order to translate, meaning to extract useful information from large purposes and assist the criminal and legal affairs. When communicating with a human being, computer must be capable in speech recognition and processing the speech signal in phonemes and morphemes and any words, and also must be able to speak the output, or what we call speech synthetic, as two-step synthetics, or the text-to-speech, which in our built-in app we are using the text, according here, text-to-speech. We are using it in order to identify if our word is correct. According to sometimes it's translation is that, like, not all word and language can be translated. For instance, you are using ketchup, chicken, beef, although you can translate it, but you can translate it in another word or another language, but it has no meaning of it. So what we call morphology is a language used in centuries and decades and before crisis. They use it in order to have a meaning, but the meaning does not, it is broad and then expandable for us to understand it, and then AI cannot understand it, or what we call the computer translation cannot understand. So that's all for today. Goodbye.